Welcome back to my channel. Today we'll be talking about determining the density of liquids. The last video I made talked about how to determine the density of solids. Liquids are in kind of two forms. We have liquids that are more viscous than the other. And also viscosity do not play a role when it comes to the density of liquids. There are liquids that are more viscous than the other, but yet they have a very low density. Let me bring you back to this. Density talks about majorly how a substance floats on water or floats on liquids. Now you can imagine when you have a ship floating on a river or ocean. This is just the principles of density. Now, when a substance is immersed or is introduced in a liquid, there is always a force that acts against it. And this force, we call it upthrust force. Now, this upthrust acts against the substance, and if the force of the substance is heavier or mightier, okay, than the force of this upthrust, that means the object or the substance will sink. We sink. But if the force, the upthrust force or buoyancy force, is heavier than the force of the substance, that means it will push the substance up, making it to flow. Okay, and so most times when it comes to liquids, viscosity, the rate of flow or how viscous a liquid is, do not have a role to play when it comes to density. And so we're talking about how to get the density of liquids despite their viscosity. And so these are the steps on how to determine the density of the samples you'll be working with. For this experiment, you'll be working with 3 different samples or 3 different liquids, and these liquids are of different viscosity. The first thing to do there is to weigh your empty measuring cylinder. Then after weighing your empty measuring cylinder, you have to record the weight of this empty measuring cylinder. Then you add 10 ml of sample A. Of course, you're going to label your liquids, which are your samples, as sample A, B, and C. You add 10 ml of sample A, then after that you record the new weight of the cylinder and repeat this procedure for sample B and C. Now, your volume, to get density, as we have talked in our last video, in our previous video rather, is volume, mass per volume. Now, volume of these liquids is just constant by like having 10 ml. Then to get the mass of this sample, that sample A, you get to see that when we prepare our table for the result. And so this is how you are going to present your results. Okay, you have to form a table, and this table will have sample A, sample B, and sample C as the captions of the column. Then the first one there, you have to record the weight of the measuring cylinder. Let's say the weight of the measuring cylinder is 107.5 grams. Remember also that your table must be in 2 decimal places, and you must include the unit. It doesn't have units, that means you're not recording anything. It must have units. Now, let's say that you have added 10 ml of sample A to the weight to your empty measuring cylinder. Now, let's say that this weight increased from 107 to 128.60 grams. And so, for you to get the weight of your liquid, it becomes 128.60 minus 107.50 grams. So whatever you get here becomes the weight of your liquid. Now the volume of your liquid is constant because you are using 10 mils. So this becomes 10 mils, and to get the density of your liquid, that becomes mass divided by volume, which is your answer here, divided by your volume, this, and with that you get the density of this liquid. Now you just have to replicate this for sample B, sample C, sample B, and sample C. Thank you for watching. If this is your first time of coming across my page, feel free to subscribe. See you in my next video.